Okay, so I am back with the homework solutions for sections 10.5 and 10.6. Actually, all these problems go with 10.6. These are all Boyle's Law problems. Remember, for this, there's an inverse relationship between pressure and volume. So if one goes up, the other has to go down, and we should see that in our math every single time. All right, so this is the answer to A. This is the answer to B. C. And D. And now what I'm going to do is I'm going to walk you through each problem in case you have a question. Maybe you got something wrong somewhere. So let's walk through this. All right, so for part A, it says, answer the following questions using Boyle's Law. So A, a gas at 1 atmosphere occupies 5 liters. Under what pressure will the volume be 10 liters if the temperature remains constant? So just working with pressure and volume on all of these problems. So first thing we have to do is we have to identify our P1V1 and our P2V2. So P1 is 1 atmosphere. That's what we start out with. The volume we start out with is 5.00 liters. So these numbers both have 3 significant digits. P2 is what we are trying to find, and V2 is 10.0 liters. So again, 3 significant digits. All zeros after a decimal point are significant. Our formula, P1V1 equals P2V2. Plug in our numbers, 1.00 atmosphere times 5.00 liters equals P2 times 10.0 liters. So we have to get P2 by itself. To do that, we divide both sides by 10. So I rewrite my equation as this. Pretty simple algebra. Liters cancels. Those cancel. So what I'm left is P2 equals, and 1 times 5 is simply 5 atmospheres divided by 10. And you can probably even do this in your head. 5 divided by 10 is 0.500 atmospheres. Now 3 significant digits because I have 3 on my original numbers. So 1, 2, 3. Okay, going on to B. B says, a gas occupying 25 liters has a pressure of 25 psi. So that pounds per square inch, that's just psi like we talked about yesterday. What volume will it occupy if the pressure changes to 35 psi while the temperature remains constant? So identifying P1, V1, and P2, V2. The original pressure is 25 psi, and I'm lazy, so I'm going to write it as psi instead of the way they wrote it. Volume, the original volume is 25 liters. P2, what we're headed towards is 35 psi, and I want to know the new volume. So we write down our equation. Don't skip this step. you start skipping steps and you're going to start making mistakes. Okay, so don't skip anything. Don't skip writing these down. Write them down so you know that you have the correct values. Don't try to take shortcuts. So P1, 25.0 psi times V1, 25 liters, equals P2, which is 35 psi, times V2. And the same goes for all of the numbers. Don't drop off the zeros, because if you do, you're going to end up with the wrong significant digits in the end. So don't try to take those shortcuts. All right. So let's solve for V2. We got to divide both sides by 35. So 25.0 psi times 25 liters, divide that by 35 psi. Divide this side by 35 psi. PSI cancels, we're left with liters. We want volume, looks good. So V2 is 625 liters divided by 35, which ends up being 17.9 liters. So again, I increase the pressure, I decrease the volume. So that inverse relationship works. All right, going on to C. C says a 3.5 liter sample of neon gas has a pressure of 0.950 atmospheres at 20 degrees Celsius. What would the volume be if the pressure increased to 1.5 atmosphere and the temperature remained constant? Okay, so again, let's identify P1, V1, and P2, V2. So P1 is 0.950 atmospheres. V1 is 25 liters. Or no, wait, I'm on the wrong problem. 3.5. I have to look at the right problem, not the previous one. P2, V2. The new pressure is going to be 1.5 atmospheres, so I am increasing the pressure, so I expect the volume to go down. And we'll see if that happens. If it doesn't, we did something wrong. So that's a good check right there. If after you end up doing your math and the number does not go the way it should, then you better go back and check. So P1 V1 equals P2 V2. Plug in our numbers, 0.950 atmospheres times 3.5 liters, 1.5 atmospheres times V2. Let's divide both sides by 1.5 to get V2 by itself. So 0. That atmospheres cancels out, leaving us with a volume unit. That cancels, so V2 equals, multiplying these two numbers together, 3.325 liters over 1.5. Do that division and I end up with 2.22 liters. Now, 3 significant digits in all of these numbers up here, 3 significant digits down here. All right, and finally, question D. A gas with a pressure of 845 torr occupies 11 liters. What will the pressure be for a volume of 2.5 liters if the temperature remains constant? So again, identifying our starting and ending pressures and volumes. So P1 is 845 torr. V1 is 11 liters. P2 is what we're trying to find, and V2 is 2.5 liters. Now our volume went down, so we expect our pressure to go up. So let's see what happens there and make sure that that's what happens. So P1 V1 equals P2 V2. Plug in my numbers, 845 torr times 11 liters. P2 is what I'm trying to find. V2 is 2.5 liters. Divide both sides by 2.5. My volume units cancel out, leaving me with a pressure unit, which is what I'm after. Those cancel. So I'm left with P2. When I multiply the top together, I get 9,295 torr. I'm going to divide that by 2.5. And I get 3,720 torr. Now on this, I have 3 significant digits up here. I have 3 significant digits here. I want to make sure I round off to the tens place because this 0 is not significant because there is no decimal after it. So that is Boyle's Law, and the next video will be about more gas laws. So be looking for more demo videos, and I'll see you later.